Hi, this is Algebra 1, Module 7, Lesson 4, a square deal. So, going back to the quilts, remember Optima's Quilt Shop? She bases her designs on quilt squares that can vary in size. So, she calls the length of the side the basic square x. The area of the basic square is the function a of x equals x squared. And this way, she can customize the designs by making bigger squares or smaller squares. So, number one, sometimes a customer orders more than one quilt block of a given size. For instance, when a customer orders 4 blocks of that basic size, the representative writes up an order for a of x equals 4x squared. Model this expression with a diagram. So what this looks like is we've got our basic x squared, right? And we have 4 of them. Now, they're not quite exact, but I'm trying here. So whatever this is, we have 4 of them, and they're all um, x squared, right? X by x. Okay, so one of the customer service representatives finds an envelope that contains the blocks pictured below. Write the order that shows 2 equivalent equations for the area of the blocks. Well, one way we can do it is say that we have x on this side and 3 over here, x on this side, 3 over here, and we have the same thing over here. So we have 2 of the x plus 3 squared. We also could say I have a total of 2x squareds. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 x's, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 of the separate ones. You know what I can also do? We're going to do a third one. You're going to get your money's worth here. I have 2 times, what does just one of these have? Well, an x squared plus 6 x's plus 9 of the ones. So here we actually did 3 equivalent equations for these boxes. All 3 of those work. Okay, next page. Write equations for the what equations for the area customer service write if they received an order for 2 blocks that are squares. Both have the dimensions increased by 1 inch in comparison to the basic. Okay, so I have 2 blocks that the dimensions were increased by 1, right? So I'd have 2x plus 1 squared. So an equivalent equation would be 2, and then I could split this out. We know that it's x squared. We know it's plus 2 of the h's, right, is b. So 2 x's plus h squared, which is 1. And we can even go farther than that. Let's distribute the 2 to every single number. 2x squared plus 4x plus 2. So I gave you 3 again. Get the bonus. Verify with the diagram. So I have an x squared plus 1 on each side, and I have 2 of those. And so I have 2x squareds, 4 of the x's, oh, well, that line's not working, 4 of the x's, and I have 2 of the separate boxes. So it works. If customer service receives an order for 3 blocks that are each squares with both dimensions increased by 2 inches in comparison to the basic blocks, we have 3 of them. Show 2 different equations, verify with the model. So we're going to still do the 3 and verify. So I have 3 blocks, both dimensions increased by 2 inches. So that equals 3 times, when I expand this out, I have x squared plus 2 h's is 4x plus h squared is 4. And then I expand that out yet again by distributing my 3 to each number. I have 3x squared plus 12x plus 12. So what this looks like is I have x, and then it's plus 2 on both sides, x plus 2. Not great. That is not a great picture. On both sides. You can't even see my 4 on there. And then I have plus, I'm going to make these bigger, plus 2, plus 2. So that one's a little bit better. So again, I have 3x squareds. I have 2, 4, 6, 8, 10, 12 x's. And then there's 4, 8, 12 of these little guys here. All right, Clementine is at it again. This dog is going to learn not to chew up the orders. She also chews up her shoes, but that's another story. Here are some of the orders that have been chewed up, so they're missing the last term. Help Optima by completing each of the following expressions for the areas that describe a perfect square. Then write 2 equivalent equations for the area of the square. So what I'm going to do is do a diagram first. I have 2x squareds, and if I have to get 8, I have to split up those 8 between the 2 others. So that means I need to have 4 on this one and 4 on this one, right? 1, 2, 3, 4, which means I need to do the same thing over here. So I have 2 x's. I have 2, 4, 6, 8, 2x squareds, 8 x's. So that gives me 4, 8 of my little boxes. Now, how does this work mathematically? Well, if I undistribute that 2, then I'm left with x squared plus 4x. And so I know this, to get C, a perfect square, I have to have the 4, which is 2, and then square it. So it's a 4, which also means that this would be 2x, oh, that's weird. What's my h? It's the square root of 4 plus 2 squared. Okay, so let's try it with this one. First, I'm going to undistribute 3. So 3 gives me x squared plus 24 divided by 3 is 8x. So to fill in my blank, I have to half the 8, which is 4. 4 squared is 16. So if that's the case, then it should be 3 times x, half of 8 is 4. So it's plus 4 squared. And so if I did that in box style, I would have to have 3x squareds, and I'd have to split 24 between them, which means I'd have to have 8 on each, which half of them would have to be 4. So I would have to have, split this up into, do another row over here, fours. So then each one would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these guys. So 12 times 3, or no, 4 by 4, 16. So I have 16 on each one. 16 times 3 is 48. So to finish this up, it would be 48. There's 16 of the little guys on there, and I'd have to have it on each of those. Okay, let's see if Clementine has more for us. Nope. Okay. So for these next ones, sometimes the quilt shop gets an order that turns out not to be more or less than a perfect square. Customer service always tries to fill with perfect squares, but at least they start there and then adjust as needed. So they always write their equations in a way that relates to the area of the closest perfect square. So here's a real mess. They got this order. A of x equals 2x squared plus 12x plus 13. So we need to help them figure out an equivalent expression for the area using the diagrams. Well, okay. So we have two x's, right? Two x squareds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 means I have to have 6 on each, right? Which means each side needs to have 3. Okay, so let's go ahead and put, not going to worry about the little guys yet. That's not a very good one. Undo. There we go. Okay, so now I have 13. Well, 3 by 3, this one would have 9, right? So if 1, 2, 3, 4, 5, 6, 7, 8, 9 is used up, then I only have 4 for this side. So my perfect square would be x plus 3, right? 1, 2, 3. So it'd be x plus 3. I have 2 of them, but the problem is I have 4. I need 9. So that means I'm missing 5. So I need to subtract 5. So I have this perfect square minus 5, right? 6x gives me 12 when I multiply it by 2, but I need to have 3 squared is 9. 9 times 2 is 18. I needed 18, but I don't have enough. I'm 5 short. So that's how we can come up with this using the pictures anyway. So I'm going to, let's write this just a minute here, slightly different. I put missing 5. So they write that as a minus 5. Okay, so now she really needs to get organized. Here's another scrambled diagram. We need 2 equivalent equations for this area. So let's just write out what we have first. We have, let's do green for this, 3x squareds plus 1, 2, 3, 4, 5, 6, 6x's plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus 10. All right. Well, if we put these into diagrams, I have 3 of these. And if I split this into thirds, that gives me 1 of each on the sides, right? This gives me 1 more on each side. Okay, so there's 3x squareds plus 6x's, but here I only have 3. I only used 3 on here. So let's go ahead and x plus 1 squared, right? I have x plus 1 on each of these, and I have 3 of them. And I only used up 3, but I have 7 extra. So I have that perfect square plus 7. So this equals 3x plus 1 squared plus 7, because I have 7 extra over here. All right, keep going. So Optima realized that not everyone is in need of perfect squares. Not all orders are coming in as expressions that are perfect squares. So determine whether or not these are perfect squares and explain why the expression is or is not. If it is not a perfect square, find the perfect square that seems closest to the given expression and show how it can be adjusted. So here we go to play around with these. So let's see. If I take just these two, I would say x plus half of 6 is 3, right? So my perfect square is x plus 3 squared. And that should be a plus 9. So I only need 9 of those. So how many extra do I have? I have 4 extra. So I plus 4 on the end. A of x equals x plus 3. Do you see why we're doing these perfect squares before? All right, let's try B. So here, again, x half of negative 8 is negative 4. So minus 4. Negative 4 squared is 16. So this one is a perfect square. Was I supposed to say, why is it not? Explain why it is, why it is not. No, I have 4 extra. This one is a yes. We're good. Okay, so for C, let's do purple for this one. Okay, I'm going to scroll this up. So just looking at these guys, it would be x minus half of 10 is 5. And so if I were to fill in the blank, I would need to have plus 25. Well, I have a minus 3. So I have less, not even 25, not even 3. I have negative 3. So I am missing actually 28 because I'm missing the 25 and I'm missing the 3. So that is a minus 28. So a of x equals that. So this is a no. I'm missing. That's not very. No, I'm missing 28. Okay, so for this one, no, what I didn't do, a of x. Okay, back to purple. All right, so this one, we have to undistribute that 2. So 2, I'm just going to do x squared plus, that would be 4, 4x. Okay, so half of 4 is 2. Oh, I don't need the squared inside there. Okay, so just worrying about this part here. I undistributed the 2. I have 4. Half of 4 is 2. So here's where it gets a little more complicated. So 2 squared is 4. And then I have to double it because we've got this over here that's 8. So I should have a plus 8. But instead I have a plus 16. So I have 6 extra. Let's do keep with our terms of extra. I have 6 extra. So this one's a no, and I'd actually put a plus 6 on the end. All right, this guy down here. We have a 3 in the front. So let's take our 3 out. That would be a negative 10x if I undistribute it, right? So x half of negative 10 is 5 squared. And so if I were to complete that, it would be plus 25. Well, oh, wait, just a moment. I forgot. Plus 25 times 3 plus 75. So this one is a yes. Because if I multiply that 3, then we're okay. All right. How about this one? Let's take out the 2. Half of 22 is negative 11x. Ooh, so this one's a little more complicated. So half of 11 would be x minus 11 halves squared. Okay, so 11 halves, oh, this one's ugly. So 11 halves squared is 121 over 2. So I have 121 over 2 times 2, right? So times 2 gives me a 121. So I should have 121. Yes, should be a plus 121, but it is not, right? Am I doing this right? I feel like I'm doing something wrong. 121. Oh, force. Here we go. That's what's wrong. Then it's not right here. 121 force. So I have 121 over 2. Well, I need to, um, let me think here. So I should have 121 over 2, which is bigger than 11, so I don't have enough. So I'm going to subtract, but I need to take 121 over 2 minus, I'm going to double that so I can put it over 2. 22 over 2, which 121 minus 22 is 99, 2. So I'm going to minus 99, 2. A of x equals. That was ugly, but we figured it out. And so that's what works on that one because we're missing. So it's a no. Okay. So now we got to generalize. So given the expression of our standard form, describe a step-by-step process for completing the square. I'm going to go down here to do it. All right. So let's just start here. If a equals 1, so if we don't have a multiplier, it works a lot easier, right? First, we have to divide b by 2 and square it to get c, right? That gives us our c. And then we have to add b over 2 to x in the parentheses and subtract b squared over 4 from c. So what we did, just to confirm here, is we took that in half and we squared it to figure out what it should have been. But then we had to add our what should have been our perfect c, right? We had to add our perfect square to the x in there. And then we had to subtract what was missing from it, right? So this is kind of the algebraic form from it. Generalize. And then 3, so basically what we're doing is x minus b over 2, right? Because we did that to get our h, b over 2. And then we had to add our c, which is what we did up here, right? We figured out what we added up here. And then we had to take away our b squared divided by 4. We had to take away whatever, find the difference between these guys, what was there and what wasn't there. Okay, but if a is not equal, 1. It's a little more complicated. 1 factor A out of the first two terms, right? We didn't even look at the third term when we were factoring out. Then we divide B by B over A by 2 and square it. So when we divide it out, we divided it out, B over 2, and then squared it to get our number at the end, what should be the perfect square. And then we had to add B squared divided by 4A squared to X in parentheses and subtract B squared divided by 4A from C. So again, we had to, this is kind of the algebraic way of writing this, what we did, because we had to multiply, let's see, here we are. So we had to divide it out to get here, we had to square it, and then multiply it by 2, and then figure out what our difference was here. So if we're trying to make it super generic, this is about all those algebraic pieces we were doing with it. So thanks for joining us. Um, we'll see you next time.